trigonometry and measurement. So we have the right angle triangle PQR, which represents the cross section of the triangle prism below. So we have a triangular prism. Now we should know what a prism is. Well, a prism is basically a shape, a solid shape, with a cross section that is congruent all the way through. So it has two ends that are congruent, and that shape is uniformal all the way through. So we have the right triangle here, right? It's congruent to this right triangle here. So we've seen that both ends are identical. And that's what we mean by congruent. So like this angle theta here is the same value of this angle right here. Right angle to right angle. This angle here, same as this angle here. The length of this side TV matches QR. The length of PQ matches ST, etc. Now, so we have the right angle triangle here. PR, length is 13 centimeters. QR is 5 centimeters. And PQ has an unknown length of X centimeters. Angle QPR, Q to P to R, this angle right here has an unknown measurement of theta. And the length of the triangular prism, so in other words, R to V will be 10 centimeters, which is the same distance as Q to T or P to S, 10 centimeters. Now, what we're asked to determine though, so we want to find the length of the side PQ. And PQ is the side of the right angle triangle. Now, we should know the size of the right angle triangle. Opposite the right angle is the side called the hypotenuse. And we have another length of the right angle triangle. So once we have two sides and we want to find a third, we can simply use the Pythagorean theorem, or Pythagoras theorem. C squared equals A squared plus B squared. Now the hypotenuse is the side that faces the right angle, and that's denoted as C in this Pythagoras or Pythagorean formula or theorem. And so C is 13, so we're going to square C, which is equal to any one of the other two sides. So A and B can be represented as X or 5. It doesn't matter which one is which. The order in addition doesn't matter. The most important thing is identifying the hypotenuse, the side that is facing the right angle. And that's given as C in the formula. So 13 squared, C is 13, the hypotenuse is 13, so we're going to 13 squared equal 5 squared plus B squared. And this B, now we're going to just consider that to be X, so X squared. We have 169 equals 25 plus X squared. To find X, we need to transpose the 25 first of all. That's going to give us 169 minus 25 equal X squared. So we have that X squared, and working out this side will give us 144. Finding X, we basically square root both sides, and that will give us X equal 12. So that's 12 centimeters. And if you're familiar with the Pythagorean triple, you know this was a Pythagorean triple because the hypotenuse is 13, so this is a 5, 12 to 13 ratio triangle. You were given the hypotenuse of 13 and another side of 12 or 5, so you know the other side has to be 12. Alright, so just a little trick in the trade to figure that out. So we know the hypotenuse is 12, the other side is 5. Sorry, the hypotenuse is 13, one side is 5, the next has to be 12. And so PQ, which is X, is equal to 12 centimeters. Now we're asked to find angle QPR. So what is angle QPR? Angle QPR. So angle QPR is the same as angle theta. Q to P to R. So that's angle theta we're talking about. So how will we calculate that? So let me just do a little quick sketch of the triangle that we have. And it's a right angle triangle. So here we have theta. This is our 90 degrees angle. This side is 13, this side is 5, this side is 12. So in order for us to find this angle, we're going to consider this to be well, it's an acute angle for sure. And since we have all three sides, we can take any one of them. We know this side is the opposite, because it's opposite theta. In other words, theta faces that angle. This side is the hypotenuse, because it faces the right angle. This side is opposite theta. And this side is the adjacent, because they have both the right angle and theta. That's the adjacent side to theta. So I have all three sides, so I can use any trig ratio I want. So let's use sine. Or in fact, let's use tangent. We know the formula for tangent is tan theta equal opposite over adjacent, which implies that tan theta is equal to, what's the opposite? Opposite is 5 over the adjacent, which is 12. For me to find tan, I need to transpose it. So I have theta is equal to tan inverse of 5 over 12. Now, it is important you put that in your calculator. You're going to need to press shift or second function. That's F2 and then ND and then F on the button. That's second function. Or if your calculator doesn't have that, you should have shift. You can press that button, then you press the tan, and you can see tan inverse appears on your calculator. If not, then you might have to put the numbers first, and then you do just that. So tan inverse of 5 divided by 2. A good practice would be to put open bracket 5 over 12 and then put close bracket, then equal. And your answer should be 22.6 degrees. Alright, so now we are asked to find the area of triangle PQR. Now we can use any formula since we have a right angle triangle. We have the angle here, which is 22.6 degrees. So we can actually find what angle this is. So we can actually use any of the three area formula for triangle. But let's use half base times height for now. Half times the base times height. The reason we can use this formula is because we have two sides that are perpendicular to each other. In other words, two sides that meet at 90 degrees. So it's going to be half multiplied by the base. So the base and height will have to be the two sides that form the 90 degrees. The height is a perpendicular height to the base, so they meet at 90 degrees. So the two sides that meet at 90 degrees are 12 and 5. So we have to use those in our calculation. So that's going to be half multiplied by, should be a half, multiplied by 12 fives are 60, and half of 60 is 30. So we're going to say that's 30 centimeters squared, since the length of the sides are in centimeters. So that's 30 centimeters squared for the area of the triangle PQR. That's the area for this side, which is a triangle. Now the volume of the triangular prism. The volume of a prism is given by area of cross section multiplied by the length of the prism. In other words, the length between, the direct distance between the two cross sections that are identical. So what's the area of the cross section? The cross section being a triangle, we found the area, which is 30 centimeters squared. And we're going to multiply by the distance between the two cross sections that are identical. What's the distance between this triangle and this triangle that are identical? It's 10 centimeters. In fact, we're given the length of the prism to be 10 centimeters. So we multiply that by 10 centimeters. And our volume, which is area times length, is 300 centimeters cube, because centimeters square times centimeters becomes centimeters cube. This is our volume. Now, as I mentioned before, we could have found area another way by using this formula, half times A, B, sine of angle C. So it's half. Now AB in this form, for this formula, will be the two sides that form an angle. So we could use any angle we want. So we could say we could use 12 and 13 as our two sides, being A and B. But the angle that we'd have to use would have to be the angle formed by these two sides, 12 and 13. 12 and 13, the two sides that have the lengths 12 and 13, they meet at this point and the angle is 22.6. So it has to be sine of 22.6 degrees. When we put that in our calculator, we can say 0.5, that's half, multiplied by 12, multiplied by 13, and we press times sine of 22.6, close bracket, and we get 29.975. If we were to round this off to two decimal places, well, one decimal place, we'll actually get 30.0 centimeters squared. So we see the answers are pretty much the same.